When I was a young girl growing up in the woodlands of upstate New York, I couldn't help but notice the world around me. The changes in the seasons changed my world, in flora and fauna. I would watch my father's bird feeders in the hopes of seeing birds that the winter's cold brought, or the ones that flew in duetting with the frog song of spring. Spring was a cacophony of noise, and it had always been my favorite. All animals were vying for a lover to spend the season, and little me, blissfully ignorant to the meaning of their serenades, couldn't help but enjoy every note. But why do my lovely friends only come around in the spring and summer? Did they wish to spend my birthday with me, hopping around looking for seeds and worms? Where did they spend their winters? As I got older, I began to do my own research into where my friends went, and was astonished to find that they aren't much different than some of my relatives. They spend their winters in the warmth of the tropics, feasting on plentiful food and basking in the hot sun. But how did we learn this? Did others like me wonder where their cordial friends went in the bleak winters? A research technique that is crucial to learning about bird migration and bird biology in general is the banding of birds. Scientists catch almost any size bird, record various data about them, give them a fancy bracelet, and send them on their way. These bracelets serve a purpose, though. Each are paired with an ID number issued by the U.S. Geological Survey. They are identifiers of these individuals, giving a name to each one like I did as a child. But why is it done? Why go through the trouble of wrangling an angry hairy woodpecker who seems to really enjoy hammering their sharp beak, which can move up to 15 miles per hour, into your fingers? It's not as fun as it sounds, trust me. Well, you can gain a lot of biological data about birds by banding them, like behavioral and social structure. You can find out information regarding territorial behavior, mate fidelity, territory size and fidelity, reproductive behavior. For example, which bird builds the nest or feeds the young, or how often do they do it? Or what about lifespan information? If birds are banded and then caught or seen 10 to 15 years later, scientists can estimate average life expectancies for species in the wild. Or even population studies. Mark recapture studies can be completed in areas to estimate population size of specific species. You'd mark an individual with an individual band, and then maybe you test the next year, or even a few weeks later. You can then determine if those individuals are still in the same area and for how long. Or, perhaps more important today, bird banding can help estimate survivorship and productivity of bird populations. Using stable banding sites, meaning sites that are banded year after year, scientists are able to compare survivorship of populations that have been exposed to environmental hazards, such as pollutants, and they can use that information and compare it to that of unexposed populations to see how the populations compare. Are the exposed populations producing less young? Are they moving to a different area? Are there specific genetic mutations that we need to look out for? Additionally, this information can be used to gain additional information as to how pollutants are affecting the environment and the organisms within it. Or, what about disease and toxicology studies? Scientists can sample birds in hand for various diseases, such as encephalitis and Lyme disease. These help with monitoring the population and the spread of the disease, either within an area or across countries. But while all these things are very important, in my opinion, the most important data that can be gained from bird banding is information on dispersal and migration. All banding data is sent to the bird banding lab through the USGS, which allows for tracking of individual birds through recapture or sighting reports. This allows for estimation of migration routes, wintering grounds, nesting grounds, and migration length in terms of distance or time. Okay, so you learned all this fun information that bird banding can tell us, but why should you care about it? Well, it supports conservation science. With more and more data collected, scientists are able to determine what factors are negatively affecting bird populations in either their breeding or wintering grounds, and can help enforce regulations in these areas to help remediate population decline. It can also give us insight into how climate change is affecting birds. By looking at changes in migration timing, or when birds leave or arrive at wintering or breeding sites, scientists can infer the changes that a warming climate has on bird migration. My interest in birds and bird banding has led me to have some great experiences as well. I've been a volunteer bird bander at the Albany Pine Bush Preserve Commission's banding station for a few years now, and I can tell you, there's absolutely nothing that compares to having a bird in the hand. The Albany Pine Bush's focus species is the prairie warbler, but many other incredible and rare species are found in the park as well, including saw-whet owls, whose migration just passed through not that long ago. Bird banding is the best way to collect important data on bird species. These data are crucial to their conservation and understanding of their life history. As stated previously in this class, biosphere integrity is a very important planetary boundary that we've already surpassed. Doing research into what may be causing the decline in various bird species is a small step in the right direction, but a step nonetheless. And remember, you can be a part of the science too. If you see a bird that has a band, try to grab a picture. Or if you find a dead bird with a band, please report it to the bird banding lab from the USGS. You can contribute to bird population recovery and science. Thank you.